De-Moiver's theorem. In previous lecture, we have seen the proof of De-Moiver's theorem and what are the applications and where we need to use the De-Moiver's theorem. To find out the powers of a complex number, we have to apply the De-Moiver's theorem. Now here the question is given that if n is an integer, then show that 1 plus I whole power 2n plus 1 minus I whole power 2n is equal to 2 power n plus 1 into cos n pi by 2. Okay, so we know that the De-Moiver's theorem is used to find out the powers of a complex number. Okay, so here the complex number 1 plus I whole power 2n and 1 minus I whole power 2n. So that means we have to apply the De-Moiver's theorem. But to apply the De-Moiver's theorem, the given complex number has to be represented in polar form. That means in modulus amplitude form. Okay, so if z equals to a plus ib is a complex number, then the polar form of this one is r times of cos theta plus I sin theta, where r is the modulus of the complex number, which is equals to square root of the real part square plus imaginary part square. That means square root of a square plus b square, and argument of z theta is nothing but argument of z, which is generally written as tan inverse of what is imaginary part of the complex number by real part of the complex number. If theta is in the first quadrant, the theta is itself tan inverse of b by a, tan inverse of b by a, and if it is in the second quadrant, the theta can be written as pi minus alpha, where alpha equals to tan inverse of mod of b by a, and in the third quadrant, theta can be written as minus pi plus alpha, where alpha equals to tan inverse of mod of b by a, and in the fourth quadrant theta equals to minus alpha, where alpha equals to again tan inverse of mod of b by a. Okay, so these are the concepts we have to cover to solve this problem. So now here the first I am considering the complex number 1 plus I. Okay, then I am trying to represent the 1 plus I in polar form. Then how to represent the 1 plus I in polar form? So we know that which is in the form of a plus iota times of b. Okay, a plus iota times of b. To represent in the polar form, this has to be multiplied and divided with the modulus. What is the modulus here? A equals to 1 and b is equals to 1. Okay, here a is equals to 1, b is equals to 1. Then the modulus we obtain here, it is as square root of 1 square plus 1 square, means root 2. Now multiply and divide the given complex number with root 2. Then what will obtain? Root 2 by root 2, and direct writing this is as 1 by root 2 plus I by root 2. Okay, plus I by root 2. Okay, now we are multiplying and dividing the given complex number with the modulus. What is 1 plus I? That means a is equals to 1, b is equals to 1. Then square root of a square plus b square, square root 2 dividing with the square root 2, multiplying dividing by the square root 2. Then now we know that which is in the form of, so square root 2. Okay, I am writing here, it is as a square root 2, and 1 by root 2 can be written as, okay, we have to express as a cos theta plus I sin theta. Okay, cos theta plus I sin theta, and here we can write this theta equals to, okay, theta equals to, in the first quadrant 1 plus I means it is in the first quadrant, tan inverse what is b, imaginary part by real part, 1 by 1, which is equals to pi by 4, and we can write this is as, so cos pi by 4 theta is nothing but pi by 4 over here plus I into 1 by root 2. We can write as I sine pi by 4. Okay. So 1 plus I. Okay, so we can write 1 plus I as root 2 into cos pi by 4 plus I sine pi by 4 in polar form. But what we have to know, we have to find out 1 plus I whole power 2n. Now we need to find out 1 plus I whole power 2n. Now we can write this is as root 2 into cos pi by 4 plus I sine pi by 4 whole power 2n. 1 plus I is expressed in the polar form as root 2 into cos pi by 4 plus I sine pi by 4. Now we can write this as root 2 can be written as 2 power root 2 can be written as 2 power 1 by 2. So now we can write this as 2 power 1 by 2 power 2n into cos pi by 4 plus I sine pi by 4 power 2n. Okay, now here we can apply the De-Moivre's theorem. So what is the De-Moivre's theorem? Cos theta plus I sine theta whole power n can be written as cos n theta plus I sine n theta, which is our De-Moivre's theorem. Okay, now we need to apply this in this step. Okay, now we can write this as 2 power 1 by 2 power 2n. So we can write this as simply as 2 power n into cos theta plus I sine theta power n, cos n theta. That means here 2n into, we can write here this as 2n into pi by 4 plus I sine 2n into pi by 4. Here n is replaced by 2n. Okay, in actual De-Moivre's theorem we have the power as n, but here we have the power as 2n. Okay, now what we obtain over here, we can write this is as 2 power n. Okay, we can write this as 2 power n, and here we are obtaining it as pi by 2 and 2n into pi by 4 as pi by 2, and we can write this is as cos pi by 2 plus I times of sine pi by 2. Okay, which is the resultant of 1 plus I whole power 2n. Let's, this is as some equation 1. Now solve for 1 minus I whole power 2n. Okay, 1 minus I whole power 2n. So before that, try to simplify the 1 minus I complex number. Okay, try to simplify the 1 minus I complex number in polar form. So we can write this is as polar form as. So how we can write this is as, here r equals to z is equals to in the form of a minus I beta, sorry, a minus ib, and r equals to square root of a square plus b square, but z is equals to here 1 minus I. That means a is equals to 1, b is equals to 1, r is equals to root 2, and alpha equals to, which is in the fourth quadrant, 1 minus I real and negative imaginary. 1 minus I means in the fourth quadrant. In the fourth quadrant we can write this is a tan inverse of mod of b, means minus 1 or 1 by 1, which is equals to tan inverse 1 is nothing but pi by 4, but it is in the fourth quadrant. Theta equals to minus alpha minus pi by 4. Okay, so modulus equals to root 2 and amplitude equals to minus pi by 4. Now we can write this is as what it is, complex number z is equals to a plus ib in the polar form equals to r times of cos theta plus iota times of sin theta. Now we can write r is nothing but here root 2 into cos theta minus pi by 4 plus I into sine of minus pi by 4. Okay, I into sine of minus pi by 4. Now this is okay. Now which can be written as, so root 2 into, so cos of minus theta is simply cos theta. We can write a cos of minus pi by 4 as pi by 4 cos pi by 4, but sine of minus theta equals to minus sine theta, then we can write this is as minus of sine pi by 4. Okay, right. Now find out I power, what is I 1 minus I power 2n, okay, which is equals to, by applying here I can write the root 2 is 1 by 2 power 2n, and I'll writing over here, and what it is cos pi by 4 minus I times of sine pi by 4 whole power 2n. Now apply the De-Moivre's theorem over here. Okay, now apply De-Moivre's theorem. Apply De-Moivre's theorem for this cos theta minus I sin theta all power n. So we know that cos theta minus I sin theta all power n. Now and here 2 power 1 by 2 power 2n, it is simply 2 power n into cos, and what it is n theta cos 2n into pi by 4 minus I sin n theta 2n into pi by 4. And what is De-Moivre's theorem? Cos theta plus I sin theta whole power n, or cos theta minus I sin theta, whatever it is, cos theta plus I sin theta or cos theta minus I sin theta whole power n equals to cos n theta minus I sin n theta. Okay, cos n theta minus I sin n theta. Now we applied over here, we can write this as 2 power n into cos, and here this is pi by 2, that means n pi by 2 minus I into sine n pi by 2, okay, which is 1 minus I whole power 2n. Okay, so which is the resultant, assume it as some resultant is 2. But in the question what he is asking, he is asking the LHS he has given as 1 plus I whole power 2n plus 1 minus I whole power 2n equals to, he is asking us to find, okay, which can be written as, so we obtained 1 plus I whole power 2n as 2 power n into cos n pi by 2 plus I sin n pi by 2, okay, plus 1 minus I whole power 2n, we obtain this is as 2 power n into cos n pi by 2 minus I sin n pi by 2. Okay, so now we can take 2 power n as a common, and we can simplify this as cos n pi by 2. If we take 2 power n as a common, cos n pi by 2 plus I sin n pi by 2, okay, plus cos n pi by 2 minus I sin n pi by 2. Okay, just take 2 power n as a common, then plus I sin n pi by 2 minus I sin n pi by 2 will be cancelled out, and we can write this as 2 power n into 2 cos n pi by 2, 2 cos n pi by 2, so which can be written as 2 power n plus 1 into cos n pi by 2, which is our required RHS. Okay, which is our required RHS. So in this way, so whenever the complex number powers are given, try to represent the complex number in the polar form. After representing the complex number in the polar form, apply the De-Moivre's theorem to that powers of the complex number, then we can easily simplify the required solution. So this is the way of applying the De-Moivre's theorem in a given problem. The next questions are, find the values of the following. The first question has given 1 plus I root 3 whole power 3. Okay, so now we will try to find out 1 plus I root 3 whole power 3. So that means the question is clearly that asking us to find the powers of a complex number. So now we can find this is as, okay, so we are having in the form of a plus ib, z is equals to a plus ib. Now we need to represent as the polar form r times of cos theta plus I sin theta, okay, where r is equals to square root of a square plus b square, and theta equals to, depending on the quadrant, generally it is written as tan inverse b by a, okay, if it is in the first quadrant. Now given the question 1 plus I root 3, okay, so 1 plus I root 3 means the real part is in the what is the real part is positive and imaginary part is also positive. So 1 plus root 3, generally it is in the first quadrant, 1 comma root 3 in the first quadrant, then theta equals to tan inverse b by a. So now what is r over here? R equals to, a is equals to 1 plus root 3 whole square 3, okay, which is equals to 4, nothing but 2. R is equals to 2, and theta equals to tan inverse, okay, it is in the first quadrant, alpha equals to theta only, theta equals to tan inverse b root 3 by 1. Tan inverse root 3 is nothing but 60 degrees, that means pi by 3, okay. Now pi by 3, so we can write this question as in the polar form as, we can write this as 2 into, okay, cos pi by 3 plus I times of sin pi by 3, okay, 1 plus I root 3, okay, only the 1 plus I root 3 can be written as 2 into cos pi by 3 plus I sin pi by 3 whole cube, okay, right. Now which can be written as 2 power 3 into cos pi by 3 plus I times of sin pi by 3 whole power 3, which is in the form of cos theta plus I sin theta whole power n. So which is nothing but De-Moivre's theorem. Now here apply De-Moivre's theorem for this one. If we apply the De-Moivre's theorem, we can write as cos theta plus I sin theta whole power n can be written as cos n theta plus I times of sin n theta, okay, cos n theta plus I times of sin n theta. Then we can write this as 8 into cos pi, okay, 3 and 3 cancel out, cos pi plus I sin pi. So we know that integer multiples of sin pi is 0 and odd multiples of cos pi is minus 1 plus 0 into I. So we can write the resultant of this one is simply minus 8. So what is the solution for the first one? It is minus 8. The next question is 1 minus I whole power 8. So in the just previous problem, okay, the first problem, in this video, the first problem we have solved that 1 minus I can be written as r equals to root 2, and which is in the fourth quadrant, we can write this is as cos of minus pi by 4 plus I sin of minus pi by 4. Just watch the video in the first question, was the video of this lecture, the first question. In that one we have derived that 1 minus I in the r times of cos theta plus I sin theta is r equals to root 2, and theta equals to, in the fourth quadrant it is minus pi by 4. Then we can write this is as root 2 times of, okay, root 2 times of cos pi by 4 minus I sin pi by 4. Now what is asking the power? He is asking the power 1 minus I whole power 8. Okay, 1 minus I whole power 8. Now for this one, take the total power as 8. Okay, we can write this as, so root 2 can be written as 2 power 1 by 2 power 8 into cos pi by 4 minus I sin pi by 4 whole power 8, which is in the form of cos theta plus I sin theta whole power n. The De-Moivre theorem can be applied over here. We can write this is as 1 by 2 power 8 means 2 power 4 into, then we can write this as cos 8 into pi by 4, De-Moivre theorem. Now here you can apply the De-Moivre theorem. So what it is, cos theta plus I sin theta whole power n is equals to cos n theta plus I sin n theta. So here 8 into pi by 4. Okay, so we can write this is as, so which is equals to 2 power 4 into cos 2 pi. Okay, here we obtain this as 4 to the cos 2 pi minus I into, okay, minus I into sin 2 pi. Okay, we know that clearly for integer multiples of pi, the sign is 0, and for odd multiples of pi cos is minus 1, for even multiples of pi cos is plus 1. Then we can write as 16 into 1 minus 0 into I, so the resultant equals to 16. Then the solution for the given 1 minus I whole power 8 is equals to 16. The next question is root 3 by 2 plus I by 2 whole power 5 minus root 3 by 2 minus I by 2 whole power 3. Okay, sorry, here whole power 5. Okay, here it is also whole power 5. The question is here it is also whole power 5. Okay, so now here the first, consider the first term. What he has given the first term, root 3 by 2 plus I by 2 means I into 1 by 2. Okay, so which is the term here is given. So which is in the form of a plus ib. Okay, complex number z is equals to a plus ib, and we can write the modulus is equals to square root of a square plus b square. A square means root 3 by 2 whole square means 3 by 4 plus 1 by 2 whole square 1 by 4. 3 by 4 plus 1 by 4 means 4 by 4. The resultant equals to 1. Simply r equals to 1, and it is in the first quadrant 3 by 2 root 3 by 2 plus 1 I into 1 by 2 in the first quadrant. Then we can write the argument equals to tan inverse, okay, root 3 by 2 imaginary 1 by 2, okay, tan inverse 1 by 2 by root 3 by 2 simply is nothing but tan inverse 1 by root 3, so 30 degrees, which is equals to pi by 6. Okay, which is equals to pi by 6. So now we can write as root 3 by 2 plus I into 1 by 2, or okay, I into 1 by 2 or I by 2 is r is nothing but 1. Okay, in terms of r times of cos theta polar form plus I sin theta. So where r is equals to 1 into cos pi by 6 plus I sin pi by 6. Okay, cos pi by 6 plus I sin pi by 6. Now the question is given that root 3 by 2 plus I into 1 by 2 whole power 5. Okay, now whole power 5. Now apply the De-Moivre theorem over here. We can write this is as cos 5 pi by 6 plus I times of sin 5 pi by 6. Okay, cos 5 pi by 6 plus I times of sin 5 pi by 6. Okay, now which is for the first one, and for the second one what we can written is, so which is in the fourth quadrant. Now the theta will become minus pi by 6. Directly I am writing, so root 3 by 2 minus I into 1 by 2 can be written as, so again, so the modulus is 1 itself, and but theta equals to minus pi by 6, we can write this as cos pi by 6 minus I into sin pi by 6. So if we apply the power to this one, whole power 5 and the whole power 5, now we can apply the De-Moivre theorem over here, and we can write this is as cos 5 pi by 6, okay, cos 5 pi by 6 minus I sin 5 pi by 6. Okay, So now which is as considered as the 1 and 2, and in the question what is asking, this is a resultant 1 and this is result, between these two we need to make it as a minus. Okay, that means 1 minus 2 is our required question. So the resultant equals to, if we make this is as directly we can write it as 2i. Okay, the resultant equals to 2i times of sine 5 pi by 6. Okay, 2i times of sine 5 pi by 6, where 2i times of, and what is the value of sine 5 pi by 6, then we can write this is as sine of pi minus pi by 6. Okay, sine of pi minus pi by 6. So in the second quadrant sine is positive and even multiple of 90, then we can write this as 2i times of sine pi by 6 only. Sine pi by 6 means sine 30, which is equals to 1 by 2. Sine 30 equals to 1 by 2, then the 2 and 2 will cancel out. The resultant of the question is 1. Okay, now what is the resultant of this one? Simply it is iota. And now I think you understand how to solve the powers of a given complex number. Always try to represent the complex number in the polar form and apply the De-Moivre's theorem. We will get the required result.